The next topic we are going to cover is the scope and lifetime of a variable. And we have kind of covered this topic a little bit when we were programming in processing in the static mode. But now it's going to become quite pivotal when we are programming in dynamic mode. So in processing, the scope of a variable or the lifetime of the variable is as such. So if you have int a equals 10, and if you have, let's say, here I'm just going to say 20, then we have int b and assign 20 to that. And if this is our programming, if this is our program and this is a static program in processing, basically from where the variable is defined to the very end of the program, it's called so the very end of the program is the scope of A, and the scope of B starts from here. So this is scope of B. It starts from where it is declared. So when you declare a variable, that's where that variable is born. So we've already talked about this, that so for example, if you had another variable, if you said int c, okay, you could use c here and just say c and assign let's say 20 to c. However, if up here before declaring c you said c equals 20 or assign 20 to c, this is not allowed, right? That's a mistake. So the scope of C is from here to the end of the program. In the static mode, there is no specific end, right? It's just a basically sheet of paper. If you're programming in static mode in processing, you basically just write code, right? So there's no visible end to your program, because you can just keep writing code and continue on writing code. In the dynamic mode, remember, we're going to have things are going to be different. So in the dynamic mode, we are going to, first of all, so let's in the dynamic mode, we're going to have a setup and we're going to have a draw. Okay. So if we go back to our, and just kind of compare, if we go back to our diagram here, basically, sorry, our code here, basically here, this would be our memory. So this is our program. We have A here. It starts as 10. Then we assign it to 20. So A becomes 20. Then we're going to have B, which is also 20. We have C, which starts off as garbage. And then we put 20 in C as well. So we have one memory diagram, one chunk of memory for everything, right? Because it's static, there's no blocks of code. It's just big lump of code. Like it's just all in one file. However, in the dynamic mode, now we're going to have two blocks. So this is a block and this is a block. Okay, so things are going to be quite different. So if I have an int a and assign 20 to it, the scope of this a is from here to the end of the function. Where is the end of the function? The end of the function is when the brace is basically to the closing brace, right? So this is called scope of A. So when this function you reach the end, A is no more. So in setup, I can go right now and say A. Let me just switch back to the same color. So in setup, I can say now A and assign it to 100, and that's perfectly fine because we are in the scope of A and A exists in setup, right? But I cannot go and say A and assign 50 to A. I cannot do this. Why? A is not, this is comment, defined in draw. So it follows that each block of code or each function, so setup is a function, draw is a function, or methods. So the terms can be used interchangeably in this course. We're going to have two different memory, one for setup and one for draw. So right now the memory diagram says we have 20 A, and then we change A, so I'm just going to erase it, and the value is assigned as 100. Okay, in draw we don't have anything now. Now draw could have its own A, so I could say int A, and now in draw I have my own A and the value is garbage because I haven't assigned anything to that yet. So this should be really clear. Or I could have another variable, let's say B here, int B, and I'm going to set it to 50. Again, B only lives in draw. So setup can't see B. Setup can only see its own A, and B and draw can see its own variables. They don't share. It's kind of like two different apartments. They have different different variables. They live in different spots. So the variables inside a code block, variables inside a function, such as in draw or in setup or in draw, these are called, so let me green. So this is called a local variable. Int A and B over here, these are also called local variables. So A is local to setup. Over here, draw, in draw, it has its own A and it has a B, right? So they don't see each other. So local variables, right? And we have a variable called a global variable. And a global variable is a variable that you define on top of your program. So for example, if I wrote int x and assign it to 17, now the global variables would set, they have their own area in the in memory. So I can basically have, let me just write this in a spot. So I would basically have my global variables. So this is called global variables, and I'll have x as 17. So x here is what is called a global, or it's called external as well. variable. So this is global, where A is local. So what that means is, if I said print ln x, now draw, this is completely fine. Draw, setup knows x. Setup can see x. So global variables, all functions can see them. Local variables, only the function that they're defined in can see them. So let's do an example so hopefully this becomes very, very clear. Let's say we have int x 20, and then I'm going to have void setup, and in setup I'm going to have an int a, and I'm going to have int b, and b is going to be x plus a. And in my draw, I'm going to have an int x. Actually, I'm going to have an int x equals, let's say, 10. And here I'm going to have int y equals 30. So let's draw the memory diagram for this. First of all, we're going to have 1 for global, 1 for setup, and 1 for draw. Okay, so int x, so x we have it as global, it's 20. Then the computer, so it starts from the top, right? So first of all, we get this in memory, then we come to setup. In setup, we're going to have a as 100. Then we're going to have b, and b is going to be x plus a. So when we say x, which x are we talking about? We're going to be talking about the global a, and don't forget we can see the global a. So here, this is going to be global x. Sorry. So this is going to be 20 plus 100, which is 120. So the value of this is x is, this is the global x, and its value is 100. Now let's go to the draw function. In the draw function, we're going to have int x equals 10. Now here, draw is going to look at its own, it's declaring its own local x. So it's going to have its own local x, and the local x, the value is going to be 10, and then we're going to have y, and the value of y is of course 30. Okay, so what happens if I said print ln, if I said print the content of x, which x do you think is going to be printed? Of course, the local x. So local x is printed. I should say value, the value of local x is printed. So what is printed is 10, right? So that's the case with local and with global variables. All right, let's do another example with this. So let's say we have int a equals 30. Then we're going to have our setup, and we're going to have our draw function. So here, right away, this is gonna be our global variables, and we have a, and we can have more than one global variable, right? You can have 2 or 3, as many as you want global variables. We're going to have this as, so 30. This is setup, and this is draw. So if inside of my setup, so inside of setup and inside of draw, we don't have anything, right? Let me just change the color here. Inside of my draw, if inside of my setup, if I said a equals 100, what happens? This a, the global a, is gonna change to 100, because when we say a, that's what we're talking about. Then if I said in here int a equals 50, actually, let's if I said int a equals 50, then what happens? The global a, we're not touching anymore, right? We're going to make our own local a, and the local a's value is going to become 50, right? So here we are creating a local variable. Here we are using the global variable. So in here, if I said a and try to say a equals 50, or actually I used 50 already, so let's say a equals 60, which a am I talking about? I am talking about my local a, since I have a local a. So if you have a local a, you use that local a. If you don't have a local a, you would use the global a, right? So here, the local a is gonna be 60. So in my draw, if I have int b, and if I say b, assign the value of a to b, what happens? So what is the value of b right now? The value of b, the value of a is going to be assigned to b. Which a are we talking about? The only a that draw can see is the global a. And the global a in memory is 100 right now, so b becomes 100. So this takes practice, so hopefully you guys get some more practice with this. We're going to give you questions like this in the lab, so you can play around with it and understand it. Again, it does take practice. I'm going to do a tutorial on this, so please make sure to watch the tutorial very carefully. Thank you.